Hey, what's up, kids? I'm Mr. Catlin. We're looking at our practice problems for the week. Homework, starting with lesson 5. Problem number 1. Let's jump right in here. Table represents the relationship between the length measured in meters. That's where we're getting that. And the same length measured in kilometers. So there should be a relationship because it's just a conversion from meters to kilometers. If you didn't know, there are 1,000 meters per 1 kilometer. The prefix kilo is for 1,000. And so what we're going to do here is we're going to complete the table to start. And to be able to complete the table, we need to recognize the constants of proportionality. There's one going from right to left that's easy to recognize, multiply by 1,000. And so that means going back the other way, we can multiply by 1,000's reciprocal, which is 1 over 1,000, 1/1,000ths, or divide by 1,000. You could think of it that way. And dividing by 1,000 is pretty easy, especially if you have large numbers like this. Even if it's not large, all you have to do is take the decimal point and move it 1, 2, 3 places to the left. So this one would become 3.5. 1, 2, 3. This one would become 0.5. Lands right there before the 5. This one would become 1, 2, 3. You got a placeholder 0 between the 75. And this one right here, 1, 2, 3. You get 2 placeholder zeros before the 1 starts. And so that would be how that works. And all we're doing essentially here is taking x and we're multiplying it by 1/1,000th. So that would be what we write here for the letter. We're taking x, we're multiplying it by 1,000th of itself, and that's telling us how many kilometers. You might also write it like this. I'll accept x as being divided by 1,000. These are equivalent to each other. You could write that as well. And it wants us to write that equation, not this equation that I just wrote because these are equivalent to each other, but it wants us to write an equation for converting kilometers and meters using x for meters. So we're going to use x for meters, and we're going to use y for kilometers. All right? Just wants to write an equation. I'll write both of them, and if you have either one, I'll accept it. So the first one I'm going to write is the one that we already started writing right here. If I take 1,000, 1 over 1,000 and multiply by x, I will get kilometers, which are y's. Okay, so if I take 1/1,000th and I multiply by x, okay, the number that's over here on the left, it will give me the y's equivalent to the y value that's over on the right. And like we've been learning this week, we can swap those letters and use the reciprocal. You also could have written 1,000 times y equals x. Both are acceptable for those problems. Number 2, we are concrete building blocks, and they weigh 28 pounds each. Using B for the number of concrete blocks, all right, as soon as I see them defining variables, I'm setting up a table. B for blocks, and then it says W for the weight of the blocks. And it says they weigh 28 pounds each. So 28 would be a weight. Each would mean singular. We need to write 2 equations that relate these 2 variables. One should begin with W equals, and the other should begin with B equals. Okay, well, let's go ahead and do that. W equals and B equals. All right, so let's write the first one by catching the constant of proportionality, which is easy to grab in this one because they are 28 pounds each, so 28 is your constant to get from blocks to weight. Notice how we're multiplying the block value, B, by 28 to get what W equals. So W equals 28 times B. Write that down here, all right? Because you're multiplying B's times 28 to get the W's. And then vice versa, if you flip-flop those, B's and W's switch, then you're going to use 28's reciprocal. 28's reciprocal is 28 over 1 flipped. So 1 over 28W. No need to change that into a decimal. Just waste of time. All right, last one, number 3. We have a relationship. A store is selling rope by the meter, and this equation represents that relationship. To help you understand it a little better, I'm going to sketch a small table. P represents the price that you pay in dollars, and L represents the length in meters. Okay? And they're coming out and they're telling you that you can take 0.8 and multiply by L and get P. So I could draw this arrow. I can multiply L's times 0.8, and it will tell me what P is equal to. Okay? So for example, if I have 1 meter of rope, that would cost me 80 cents because 1 times 0.8 is 0.8 or 0.80, which in money terms would be 80 cents. Okay? So I got all of that from the equation. If you can't interpret that equation in that way, my suggestion is set up the table, think about the relationship between the two things, label the things that are there, and then you should be able to make that connection. All right, now let's answer the questions. How much does the nylon rope cost per meter? Well, I kind of already told you that with my example. 1 meter costs 80 cents. So this is 80 cents per meter. That's what the price of the rope is. How long is a piece of nylon rope that costs a full dollar? Well, we don't know that yet because we know 80 cents. So it's going to be a little bit more than a meter. Let's see how much a dollar's worth of rope would cost. So if multiplying by 0.8 tells me meters to price, then that means that going from price to meters, I can multiply by either the reciprocal of 0.8 or I can divide by 0.8. All right. I'm just going to divide by 0.8. I think that might be simpler here. So we're going to do 1 divided by 0.8. So let's see what we get when we do that. 1 divided by 0.8. It comes out to be $1. And well, it's not $1. I'm sorry, this is a length. So 1.25. So 1 in 25 hundredths, or 1 1/4 meters. 1.25 meters. And that completes our first page of homework. Hope it's helpful. You guys have a good time working on it.